Hello, in this video we will be discussing Newton's three laws of motion. Let's begin by going over some of the history behind Newton's laws of motion. The three laws of motion were originally published in 1687 as part of Isaac Newton's Mathematical Principles of Natural Philosophy. In addition to the three laws of motion, this book also set forth Newton's law of gravitation and developed many ideas now used in the field of calculus. Newton's laws of motion and gravitation are part of what is now known as Newtonian physics. In the time since Newton's death, a few special exceptions to Newton's laws of motion have been discovered. One exception is cases with very small objects such as electrons, where quantum mechanics must be used. The other exception is cases where objects are moving close to the speed of light, in which case special relativity must be used. First up is Newton's first law, also known as the law of inertia. Translated to English from Latin, Newton's first law reads, "Every body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it." Or, restated in more modern language, an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an external net force. I will define external force and net force in the next slide. In addition to its speed, an object's direction of motion will also not change unless it is acted upon. In the last slide, I stated that an object will only change its speed and direction of motion when acted upon by a net external force. An external force is a force that comes from outside of a system. It is up to you to decide what your system is, but for example, if you set a singular object as your system, an external force would be any force that originated from outside of the object. A net force is the sum of all of the forces acting on an object. Net force is a vector quantity, which means that in addition to a magnitude, it also includes a direction. In this example, a ball is falling downwards with two forces acting on it. There is a 5 Newton force due to gravity acting downwards and a 2 Newton force due to air resistance acting upwards. The unit of force is the Newton, which I will get more into when we talk about Newton's second law of motion. Also, this symbol before the F is the Greek letter sigma, and it is used to represent the sum of. In this case, net force is the sum of all forces acting on the object. Taking up to be the positive direction, we get a net force of -3 newtons, or 3 newtons downwards. Next is Newton's second law of motion. Translated from Latin to English, it reads, "The change of motion of an object is proportional to the force impressed and is made in the direction of the straight line in which the force is impressed." The important part of this to pull out is that the change in the motion of an object is dependent on the mass of the object and the net force acting on it. This law shows us that the net force is directly proportional to acceleration, so when net force increases, acceleration also increases. This law also shows us that mass is inversely proportional to acceleration, so a higher mass will lead to a lower acceleration for the same net force. This law is where we get the equation F equals ma. F equals ma is net force equals mass times acceleration. In this equation, mass is given in kilograms, acceleration is given in meters per second squared, and net force is given in newtons. A newton is a derived unit representing a kilogram times a meter per second squared. Finally, Newton's third law of motion says that to every action there is always opposed and equal reaction, or the mutual action of two bodies upon each other are always equal and directed to contrary parts. This can be restated in more modern language as, for every action there is an equal and opposite reaction. This law is derived from the conservation of momentum. The law of conservation of momentum states that in a closed system, net momentum always remains constant. An example of this law is that if you push on a wall with 5 newtons of force, the wall will always back on you with a force of 5 newtons but in the opposite direction. This law also applies to long-range forces such as gravity. For instance, when I jump, I pull the earth up towards me with the same force that the earth pulls me down to it. I hope you have learned some useful information from this video about Newton's 3 laws of motion. The specific web pages I referenced will be linked in the description below. Thank you for watching and have a great day.